Today we're going to be working with the quadratic formula, which is another method to solve quadratic equations. We have this little song that we sing when we use the quadratic formula, and it goes to the tune of Pop Goes the Weasel. So here's a reminder of how the Pop Goes the Weasel song actually sounds.
Round and round the cobbler's bench, the monkey chased the weasel. The monkey thought 'twas all in fun. Pop goes the weasel, a pig.
And we only use the first verse because the quadratic formula is pretty short. So here goes my attempt at singing the quadratic formula song. You can read the words above and I will be pointing to the formula. X equals opposite b plus or minus the square root of b squared minus 4ac divided by 2a. So you can sing that Pop Goes the Weasel song to remember the quadratic formula, and it'll probably get stuck in your head. You'll probably hear people singing it all around school. So this quadratic formula is used to solve, that color's not easy to read, we'll try a different one, is used to solve quadratic equations. Now these quadratic equations need to be in standard form. Standard form for a quadratic equation is ax squared plus bx plus c equals 0. So when you're solving a quadratic equation, what you're going to be working with really is just the coefficients, which are the a in front of the x squared, the b in front of the x, and then the c, which is the constant term. So we should get some practice solving these. Here is example number 1. X squared plus 5x minus 6 equals 0. Now the numbers that we're going to be using in the quadratic formula are the a, b, and c that are in standard form, a, b, and c. So in this first example, the a is in front of the x squared. So for problem number 1, a is equal to 1. The b is in front of the x term, so b is positive 5. And then the c is the constant term, so c is negative 6. And then we're just going to plug those into the quadratic formula and work it out, following the order of operations. So we'll start with x equals opposite b. Since b is positive 5, it will be negative 5. Plus or minus the square root of b squared. 5 squared is 25. Minus 4ac, that means times a times c. And then divided by 2a. So 2 times 1. And it's important to remember you get that entire problem divided by 2 times 1. This denominator has a lot of power. It's dividing both of these terms in the numerator. So make sure it gets drawn all over too. And then we're going to work on simplifying what's inside the radical. Usually what I do is I kind of work this problem out, this 4 times 6, 1 times negative 6. And keep in mind you have a negative out in front. So I have 4 times 1, which is 24, times negative, 4 times 1 is 4, times negative 6 is negative 24, and then the opposite of that. So what I'm going to have under the radical is 25 plus 24. It's really important to watch those signs under the radical. And then all divided by 2 times 1, which is 2. And then we're going to simplify the radical. So x will equal negative 5 plus or minus the square root of 25 plus 24 is 49. All divided by 2. So x equals negative 5 plus or minus 7 divided by 2. Now this reminds me of when we were solving with the square root method. If we have a problem that can be worked further, such as negative 5 plus 7 and negative 5 minus 7, we need to do that. So x is going to equal negative 5 plus 7, which is 2 divided by 2, so x is 1, or x is going to equal negative 5 minus 7, which is negative 12 divided by 2, which is negative 6. So this problem had two solutions, 1 and negative 6. Let's look at one that works out differently. Let's see, 2x plus 1 equals negative x squared. Keep in mind that the quadratic formula requires that that quadratic equation be in standard form. So we're going to need to start by moving this x squared to the other side. And we want to put it in front of all the other terms because it's our leading term. So we'll have x squared plus 2x plus 1 equals 0. Again, we're only using the coefficients out of this problem. So a is in front of the x squared, so it's 1 again. B is in front of the x, so it's positive 2. And c is positive 1. C is the constant term. So let's work this into our quadratic formula. X equals opposite b plus or minus the square root of b squared minus 4ac divided by 2a. Now we're going to work inside this radical. So we have 4 times 1 times 1. 4 times 1 is 4, and then times 1 again is 4. So under the radical, what we really have is 4 minus 4, which is 0. We have negative 2 plus or minus the square root of 0 all over 2 times 1, which is 2. Now the square root of 0 is 0. So this is really negative 2 plus or minus 0 over 2. And since the square root of 0 is 0 and negative 2 plus 0 would be 0, so x equals negative 2 plus 0 over 2, which is negative 1. Or x equals negative 2 minus 0, which is negative 2 divided by 2, which is still negative 1. This quadratic equation only has one solution, and it is negative 1. But notice that it repeated itself because we were adding and subtracting 0. Well, that happens anytime the number under your radical is 0. So let's make a note of that. This number under the radical is called the discriminant. Notice that in this problem, the discriminant is 0. So let's make a note. When the discriminant is 0, that's going to give you one real repeated solution. In the problem that we worked just before that, notice that the discriminant here was positive. So when your discriminant is positive, that's going to give you two real solutions. And those are what we call distinct real solutions. In other words, it's not a repeated solution the way this one was. There were two solutions, but it was really the same one. If you still, well, you should still have your notes in front of you. So let's go back up to the top and look at this quadratic formula again. Something that I want you to notice is that the value for b squared, this b squared, is always going to be positive. Because if b is positive, we'll be squaring it. Positive times a positive is a positive. If b is negative and we square it, a negative times a negative is a positive. And I also want you to remember that this means the opposite of. That b term in the front, when you take opposite of b, it's not always going to be a negative number. So be careful of that as you're working. Let's maybe look at a couple of other examples to see other ways this quadratic formula might look. How about 3x squared plus 18x equals negative 36? The first thing you should notice is that this quadratic equation is not in standard form. We need to move that negative 36 over to the other side so that we have it in standard form. 3x squared plus 18x plus 36 equals 0. And then we're using a is 3, b is 18, c is 36. Okay, so let's work the formula. X equals opposite b plus or minus the square root of b squared. 18 squared is 324 minus 4ac divided by 2a. This problem has a lot bigger numbers. That's okay. So x equals negative 18 plus or minus the square root of 324. Now let's look at how this is going to work out. I'm going to take 4 times 3, which is 12, and then 12 times 36. So that's actually 432. You want to watch your signs, so I'm actually taking 324 minus 432. Minus 432. So watch whether that's adding or subtracting. And then divided by 6. Which gives us x equals negative 18 plus or minus the square root of negative 108 divided by 6. Now here's a different value for the discriminant. This time the discriminant is negative. Now what happens when we have a negative number under a square root? Well, let's break down this 108. So when we have 108, remember we want to break that down into its factors. 108 could be 2 times 54. 2 keeps going. 54 is 6 times 9. So 2 times 3 times 3 times 3. Let's see what comes out. Remember, they come out in pairs. So I have a pair of 3's that comes out, turns into a 3. I have a pair of 2's that comes out, turns into a 2. And then I have this 3 that stays in. The other thing I have going on is this negative under the radical. Remember, a negative under the radical comes out and turns into an I. So outside the radical, I have a 2 times a 3 times an I. So I'll have 6i. Inside the radical, I will have a 3, so 6i square roots of 3, all divided by 6. We've talked before about simplifying problems that look like this. I'm going to write it a little bit bigger so we can really see what's going on. Divided by 6. When we've had problems that look like this, we need to look to see, can we simplify it? And what we're looking for is if a number, all 3 of the integers, the 2 terms in the numerator and the term in the denominator, can be divided by the same value. And those are all divisible by 6. So we'll go ahead and simplify that way, and we will get x equals negative 3 plus or minus 2, oh, not 2, just I times the square root of 3. And then it would all be divided by 1. We don't need to write that divided by 1. Remember, we can think of this as two separate solutions. X equals negative 3 plus I square roots of 3. X equals negative 3 minus I square roots of 3. Remember what those are called. When you have a plus bi, a minus bi, those are called complex conjugates. So whenever you have a discriminant that is negative, your solution is going to be two complex solutions that are conjugates.